This is Algebra Lesson 2-4, solving equations with variables on both sides. A very important vocabulary word in this section is called an identity. It's an equation that is true for every value of the variable. We'll talk more about identities later in this lesson. When solving an equation with variables on both sides, you're going to use the addition and/or subtraction properties to get the variables on one side of the equation. It really doesn't matter which side of the equation you get all your variables on, as long as you get them on one side only. It may be easier to add this or subtract the variable term with the smallest coefficient, as it will often result in a positive coefficient. Not always, but most of the time, which will give you a less chance of making a sign error. Some people always like to move the variable to the left-hand side. Some people always like to move the variables to the right-hand side. Some people don't care. For me, it all depends. I like to try to keep my variables positive at all times, so it all depends upon which side I intend to move them on. It's all up to you. It's an individual preference. Do what you like best. All right, let's practice a few of these. Let's say we have the equation 7k minus 4 equals 5k plus 16. Remember what I said in earlier lessons, that the equation is divided into two sides by the equal sign. So if my equal sign is here, where I've drawn my green little highlighter line, that means that on the left side of that green line is one side of the equation, and on the right side of that green line is the other side of the equation. As we can clearly see, we have a 7k on the left-hand side and a 5k on the right-hand side. I need to get all the k's on one side of the equation. So I like to get my variables positive, so I'm going to subtract 5k from both sides of the equation. So I will do that first, and 7k minus 5k is 2k. I still have my minus 4, and that equals 16. Now I need to move the 4 over because I need to get the k's by themselves. So I will add 4 to both sides of the equation, and I will get 2k equals 20. To get k by itself, divide by 2, so that k is equal to 10. And of course, we should check our equations. I'm sure you're tired of checking them, but it's a good idea to practice it. So we have 7 times 10 minus 4 is supposed to equal 5 times 10 plus 16. So that's 70 minus 4 is supposed to equal 50 plus 16. Well, 70 minus 4 is 66, and 50 plus 16 is 66, so that checks. All right, problem number 2. Well, before we can move all our variables to one side or the other, we do have to do some distribution here. So make sure you follow the typical processes of solving equations, which in this case, we have to distribute before we can do anything about figuring out what side of the equation we're going to put all our variables on. So I distribute my 2. I'm going to get 2c minus 12 will equal 9c plus 2. Okay, like I said, I like to have my variables positive, and as you can clearly see, I have a 2c on the left-hand side and a 9c on the right-hand side, so I'm going to subtract 2c because I like my variables to be positive. Not that it matters, I just do, if at all possible. That's going to give me negative 12. Don't lose that negative sign on your 12. 9c minus 2c is 7c plus 2. To get the c's by themselves, I'll subtract my 2. And I will end up with negative 14 equals 7c. To get c by itself, divide by 7. And you get negative 2 is equal to c. Okay, and again, I will check this to make sure that it is correct. So I'm going to have 2 times negative 2 minus 6 will equal 9 times negative 2 plus 2. Negative 2 minus 6 is negative 8, so 2 times negative 8 is going to equal negative 18 plus 2. This is going to be negative 16. Negative 18 plus 2 is negative 16, so it definitely checks. All right, let's take a look at problem number 3 here. So here we're going to have to distribute twice before we can work on our getting the variables on one side of the equation or the other. So make sure that you distribute both sides of your equation. So 2 times 3x is 6x. 2 times 1 is 2, and that's going to equal 4 times x, which is 4x. 4 times negative 5, and remember, if it helps, do plus a negative here, so you won't lose your sign. 4 times negative 5 is negative 20. All right, I need to get all my variables on one side or the other. I have a 4x on the right-hand side, a 6x on the left-hand side, so I'm going to subtract 4x here, subtract 4x here. That's going to give me 2x plus 2 is equal to negative 20. Subtract 2, 2x is equal to negative 22. Divide by 2, so x is equal to negative 11. And again, we will check it. 2 times 3 times negative 11 plus 1 is supposed to equal 4 times negative 11 minus 5. So 3 times negative 11 is negative 33, plus 1 is negative 32, so 2 times negative 32 is supposed to equal negative 11, and negative 5 is negative 16. 4 times negative 16. This is going to be negative 64, and this is also going to be negative 64, so it does check. So negative 11 does work. All right, let's take a look at some real-world problems here. Lorelei pays someone $35 to clear the snow from her driveway. She wants to buy an electric snowblower for $689 so that she can clear her own driveway. If the area that Laurel lives in has an average of 5.2 snowfalls each season, how many seasons will it take her to break even on what she spent on the snowblower? All right, so in other words, she wants to know how many times would she have to pay somebody to clear her snow off her driveway to make it worthwhile for her to buy a $689 snowblower. So basically, that's going to be how much money does it cost her per season to pay for somebody to take the snow off of her driveway, and then figure out how many seasons she's going to have to do that for in order to figure out how much it's going to cost us to exceed $689. All right, so the variable, how many seasons will it take to break even? Okay, so if it's seasons to break even, I'm going to just let x equal the number of seasons. And I know that the cost that she pays to clear the snow, cost to clear snow, multiplied by the number of times it snows, times the number of seasons, has got to equal the cost of the snowblower. That would be breaking even. Okay, so let's figure this out. The cost to clear the snow, well, she pays $35 every time she has somebody clear the snow off her driveway. Times that, and we're going to multiply that by the number of times it snows. Well, she gets 5.2 snowfalls per year, so we're going to multiply that by 5.2, and times the number of seasons, we do not know that, so that's going to be multiplied by x, and that's going to equal the cost of her snowblower, which was $689. Okay, so we have 35 times 5.2 times x equals 689. So if we take 35 and multiply by 5.2, we're going to get 182x is going to equal 689. If I take and solve this for the variable, I'm going to divide by 182. Divide by 182. X will equal, and it's not going to be a whole number. If you divide this out, you find that it's going to be a decimal number, 3.7857. So it's going to take about 3.8 seasons, so basically 4 seasons. Okay, so approximately 4 seasons. Now let's see if this makes sense. Let's check it out here. So if she's paying $35 for somebody to shovel off her snow, and she gets 5.2 snowfalls per year, and she does this for 4 years, how much money would she spend? Well, if we take 3.5 times, or excuse me, 35 times 5.2, that should be 182. And we multiply that by 4, you're going to get $728. So yes, obviously I had to round up. So that's going to be more than $689. So in the 4th season, she will have broken even. So somewhere in the 4th season, she will have broken even. So then it says how many seasons will it take her to break even on what she sent on the snowblower. So in season 4, she will break even. So if her snowblower has a warranty of like 10 years, it's a good deal. If her snowblower has a warranty of 1 year, it may not be a good idea for her to buy a snowblower because, you know, if it breaks down after the 1st season, she's out an awful lot of money, or she's going to have to repair the snowblower, and she still has to get the snow off her driveway herself. So those are things to consider. It's a good real world problem because, you know, sometimes we always think, oh, it'll be cheaper if I did it myself, and then we find out in the long run it really isn't. So it's a good way to double check and make sure that your logic makes sense. All right, remember I told you earlier we were going to talk about identities. Here's where we're going to talk about what an identity is. An equation that is true for every possible value of the variable is called an identity. For example, x plus 1 equals x plus 1 is an identity. Because if you solved that, you'd subtract 1 from both sides, you'd have x is equal to x. So no matter what you put in for x, 7 equals 7. That's true. Negative 10 equals negative 10. An equation has no solution if there is no value for the variable that makes the equation true. For example, the equation x plus 1 equals x plus 2 has no solution, because if we solved this equation, if I subtract x from both sides of the equation, I'm going to end up with 1 equals 2, which is not a true statement, which, since it's not a true statement, that would be no solution. So if you get an answer, then you're fine. If you get an answer like x equals 6, your equation has one answer, and that's 6. If you get an equation where you get an answer where it's true for anything, like you get 6 equals 6, or you get x equals x, then that's going to be an identity. And if you get a statement that is false, like 1 equals 2, then it's going to be no solution. So let's take a look at this first problem here. 3 parentheses 4b minus 2 is equal to negative 6 plus 12b. So let's distribute. Okay. If we distribute here, 3 times 4b is 12b. 3 times negative 2 is negative 6, and that's going to equal negative 6 plus 12b. And my brain looks at that and says, hey, what do you know? 12b minus 6 is equal to negative 6 plus 12b. They're the exact same thing. If I got all my variables on one side, if I subtract 12b here from both sides of the equation, I'm going to end up with negative 6 equals negative 6. This is a true statement. Since it's a true statement and will always be a true statement, that means this particular equation is an identity. So the answer is not 6 equals 6. The answer is it's an identity. No matter what we put in for the variable, it'll make a true statement. Let's take a look at number 2. T plus 8 equals negative t plus 6 plus 2t. All right, so t plus 8, let's simplify first, is going to equal negative t plus 2t is t plus 6. So if we subtract t from both sides of the equation, I'm going to get 8 equals 6. That's a false statement. Okay, 8 does not equal 6. Therefore, this has no solution. So if you get a false statement, it has no solution. If you get a statement in which it's always true, like 6 equals 6 or 4 equals 4, or x equals x, then that's an identity. And if you get an answer like x equals negative 6, you just leave it as x equals negative 6. All right, so general guide to solving equations. Here's a good 5-step plan that you can follow to solve most of your equations. Number 1, use the distributive property to remove any grouping symbols. Obviously, you're going to follow the order of operations, so that would be getting rid of exponents and grouping symbols first. Use the properties of equality to clear decimals or fractions. That just makes your equations easier. Step 2, combine like terms on each side of the equation first. So simplify each side separately. Then step 3, use the properties of equality to get the variable terms on one side of the equation and the constants on the other. Step 4, use the properties of equality to solve for the variable. And the last step, check your solution in the original equation to make sure it makes sense. All right, following these properties, let's take a look at this last problem here. Okay, this last problem here, 5 parentheses x plus 4 equals x plus 2x plus 6. Well, the first step says use the distributive property. Well, we do need to do that. So let's take a look at that. Let's distribute this here. If we distribute the 5 through the x plus 4, that gives us 5x plus 20 is going to equal x plus 2x plus 6. Now before I start moving all my variables to one side of the equation or the other, I should simplify each side of the equation if I can. Left side is already simplified, so I'm going to leave it 5x plus 20. Right-hand side of the equation, the x and the 2x can be combined and become 3x plus 6. Now it's simplified. That was step 2. Step 3, get all your variables on one side and your coefficients on the other side, or constants on the other side, I should say. So subtract 3x from this side, subtract 3x from the 5x, and we're going to end up with 2x plus 20 equals 6. To get the 2x by itself, subtract the 20. So now we're going to have 2x is going to equal negative 14. And last but not least, to get x by itself, divide by 2. So you get x equals negative 7. This particular problem used every single solitary step. Not every problem will, okay? But it is a good idea to know that the steps are there, and the steps are helpful. If you can't use a step, you skip the step and go to the next step. So, all right, what is your closure question for this problem, for this particular lesson? It's right here. In the problem above, do any steps apply only to solving equations with variables on both sides of the equation? Okay, so in this problem, which was 5 parentheses x plus 4 equals x plus 2x plus 6, do any of those steps only apply to solving equations with variables on both sides? Please answer that at the end of your notes.